Hello viewers, welcome to UN College Digital Class. In today's session, I am going to discuss about derivation. In compiler design and technique, derivation plays a very important role in syntax analysis phase. Including with derivation, we are going to discuss about ambiguity in grammar, and also we will learn how to convert one ambiguous grammar to unambiguous grammar. Let's start.
During compilation, when the lexical analyzer generates number of tokens, all the tokens are passed to the second phase, that is syntax analysis phase. And the job of the syntax analyzer to check whether all the tokens are syntactically correct or not. And to perform this operation, it generates parse tree. But before generating parse tree, derivation process is implemented. If we will define derivation in compiler designing, then derivation is nothing. It is a sequence of production rules which are implemented to get the input string. Now we will discuss about two major decisions which must be taken during parsing. The first one is which non-terminal will be replaced, and the second one is we have to decide the production rule by using which the non-terminal will be replaced. It means that the two important factor we must consider, the first one is which non-terminal will be replaced, and the second one is which production rule will be implemented. And to perform this operation or to perform the derivation, there are two different approaches. Those are, first one is leftmost derivation and the second one is rightmost derivation. Actually, both leftmost and rightmost derivation perform the operation effectively, but the approaches they are doing, that differs. Now we will discuss about leftmost derivation. In the leftmost derivation, the input is scanned and replaced with the production rule from left to right. Now I am going to explain one example so that it will be clear that how leftmost derivation is taking place. Suppose the production rules are s equal to s plus s, s equal to s minus s, s equal to a, b and c. Let the input is a minus b plus c. If we will start the leftmost production, then at the first step we will take the first production rule, that is s equal to s plus s. Okay. Then we will use the second production rule, s equal to s minus s, so that our second derivation will be s equal to s minus s plus s. Then at the third step of derivation, we are just replacing s with a and the output will be a minus s plus s. At the fourth step of derivation, we are going to replace s with b so that the output is now a minus b plus s. And finally, the one s, the last s, will be replaced with c and we get the output a minus b plus c. It means that in leftmost derivation what happens, the input string, it is scanned from left to right and the element or the input string element is placed from left to right order. In this example, it is clearly visible that first we have placed a, then at the second step we have placed b, then the third step we have placed c. It is from left to right. Now we will discuss about rightmost derivation. Actually, it is just the reverse or just the opposite of leftmost derivation. In this type of derivation, what happens, the input is scanned and replaced with the production rule from right to left. Now we will take one example, the same example I have taken here, and I am going to explain the example so that it will be clear for you. The production rules are the same one, just like leftmost production. S equal to s plus s, s equal to s minus s, s equal to a, b and c. And let the input is a minus b plus c. Now we are going to implement rightmost derivation. When we will implement rightmost derivation, the first production rule I have used here, s equal to s minus s. Then the second production rule I have used here, s equal to s plus s. So at the second step of rightmost derivation, the output is s minus s plus s. And at the third step, I have replaced s with c. It is clearly visible that we are replacing element from the right to left order, but in the previous example we have replaced from left to right order. So at the next step we are going to replace s with b, and the output is now s minus b plus c. And finally we have replaced s with a, and so we get the output a minus b plus c. Now we are going to discuss ambiguity in grammar. Actually, in any grammar, when we are talking or when we are writing something, if we will use the grammar in a out of order, it means that if we will place something in different order, then ambiguity may be occurred. Somebody, maybe the other person, not able to understand what we are saying or what we have written. Okay. Similarly, in computer programming also, in compiler designing also, whatever grammar we are using, it may be ambiguous. So it is very essential to know what is the meaning of ambiguity in grammar, particularly in compiler designing. If we will discuss about the definition, then the definition may be a grammar is said to be ambiguous if there exists more than one leftmost derivation, or more than one rightmost derivation, or more than one parse tree for the given input string. If the grammar is not ambiguous, then it is called as unambiguous. Now I have summarized when one grammar is termed as ambiguous. Okay. For example, I have written everything here. If any grammar produces more than one parse tree or derivation tree or syntax tree or leftmost derivation or rightmost derivation, any one of this, then the grammar is called as ambiguous grammar. Now I am going to explain ambiguity in grammar by using a simple example. In the example, let the production rules are E implies I, E implies E plus E, E implies E into E, E implies inside the bracket, I implies empty, and 0 to 9 digit. And let the input string is 4 into 6 plus 2. When we will implement the leftmost derivation here, at that time what happens? At the first step I have used E implies E into E production rule. Then at the next step I have replaced E with I. Then at the next step I have replaced I with 4, and I have expanded E with E plus E. Okay. Then at the next step I have replaced E with I. So till now our derivated string is 4 into I plus E. Then at the next step I have replaced I with 6. So the output till now is 4 into 6 plus E. Then at the next step I have replaced E with I, and at final stage we have got the output 4 into 6 plus 2. Actually what happened here, at the first step, initially, gradually I have replaced from left to right serially in a serial fashion, E, then E with I, then I with the digit input string, and in this way finally we got the result. But if we will use some other way, then also we will get the output, and here the derivation will be like this. How? Here I have used the same production rule, E implies E into E first time as in the previous example, but I have just changed the previous example derivation production rule here. How? In the previous example, what we have used at the second stage, we have replaced E with I, but here we have used the production rule at the second step, E plus E, and so our derivated string will be E plus E into E. This is the difference. Okay. Then at the next step I have replaced E with I, and then at the next step I have replaced I with 4. So till now our production or derivation will be 4 plus E into E. Then at the next step I have replaced second E with I. So till now our output will be 4 plus I into E. Then at the next step I have replaced I with 6. So our production will be 4 plus 6 into E. Then at the next step 4 plus 6 into I, because I have replaced E with I. And finally we got the result 4 plus 6 into 2. In this way, we have proved that this grammar is ambiguous, because more than, if we can generate more than one leftmost derivation or rightmost derivation or parse tree, etc., then it is proof that the grammar is ambiguous. In order to eliminate the ambiguity in the grammar, there are some different approaches, there are some different techniques. Now I am going to explain those techniques, how we can convert one ambiguous grammar to unambiguous. Actually there are 4 different approaches. Those are adding precedence rules, fixing the grammar, using semantic, adding grouping rules. Okay, adding precedence rule, actually if we will use precedence of operator, which operator will be performed first, which operator will be performed next, in this way then we can restrict, we can limit of generating multiple derivation or parse tree. Fixing the grammar, we will fix where there is a loopholes or where there is a leakage. In this way we can also restrict. Using semantic, by using the semantic of the grammar, by using the semantic of the input string, we can make more meaningful construction of the derivation. Then adding grouping rules, also we can use some rules so that we can restrict or we can limit the construction of multiple parse tree or derivation. Now I am explaining removing ambiguity by precedence and associativity rules. All of us know that what is the meaning of precedence of operator and associativity. Unambiguous grammar may be converted into unambiguous grammar by implementing precedence constraint and associativity constraint. Actually, the precedent constraint is implemented using the following rules. The level at which the production is present defines the priority of the operator contained in it. The higher the level of production, the lower the priority of the operator. In the similar way, the lower the level of production, the higher the priority of the operator. The associativity constraint is implemented using the following rules. If the operator is left associative, induce the left recursion. Otherwise, if the operator is right associative, then use the right recursion in its production. Now here I am going to explain how one ambiguous grammar can be converted into unambiguous by using one simple example. And here I have mentioned that let the grammar is E implies E plus E, E implies E into E, and E implies ID. And let the input string is ID plus ID into ID. We know that if one grammar can derive more than one type of derivation, then it may be called as ambiguous grammar. So here, to prove that this grammar is ambiguous, I have used 2 leftmost derivation. In the case of first leftmost derivation, I have used at the first place E implies E plus E, whereas in the second leftmost derivation I have used the production rule E implies E into E. First of all, we will discuss about the leftmost derivation 1. Okay, the first rule is E implies E plus E. Then I have replaced E with ID, so now I got ID plus E. Then I replaced E with E into E production rule, so I got the output ID plus E into E. Then at the next step I replaced E with ID, so I got the output ID plus ID into E. And finally I replaced the last tree with ID and I got the output ID plus ID into ID. Okay. In case of second leftmost derivation, the first rule is E implies E into E. Then I replaced E with E plus E production rule. So the output is now E plus E into E. Then I replaced E with ID. So the output is now ID plus E into E. Then I replace the second E with ID, so the output is ID plus ID into E. And finally I replace the last E with ID and the output is ID plus ID into ID. Okay. In both the cases, we are getting the input string ID plus ID into ID, but the way they are doing the operation, that differs. Okay. Now, and it proves that this grammar is ambiguous. Now we will remove some, or we will add some rules so that the grammar can be converted to unambiguous. And here we have applied the rule of left recursion. Why? Because here the operators plus and multiplication, two operators are used here, and these two operators follow the rule of left associativity. And for that reason, the rule is, if the operators used in the grammar are left associativity following then the left recursion will be implemented. Then what is the meaning of left recursion? The left recursion meaning is very simple. The meaning is that the leftmost symbol on the right side is same as the non-terminal on the left side. Now you can see here. First, we were taking plus symbol, okay, plus operator. E implies E plus T. Here you can see that the left side non-terminal and right side symbol, okay, are same. Similarly, we are taking multiplication symbol here, or multiplication operator. T implies T into F. Here also the left side and right side, rightmost one, are same. We have to follow the rule to convert ambiguous grammar to unambiguous, and it is just opposite in case of the operators which follow the right associativity rule. Okay, and in that case right recursion is used.
I hope you have got some basic idea about derivation, types of derivation, ambiguity, and how to convert one ambiguous grammar to unambiguous grammar. The rule is very simple. Implement left recursion in case of left associativity and implement right recursion in case of right associativity. Still, if you have any doubt, then please write to me in the comment box so that I can clear your doubt. Thank you so much for watching. Have a great time.